Intro.
Okay guys, so again, hello, my name is Sir B and I'm here to discuss about our new topic, which is all about the Chapter 4 or the Approximate Analysis for Statically Indeterminate Rigid Frames. So para dito sa topic na to, meron tayong tatlong method na i-discuss. But if we have more time, i-discuss natin yung isa pang method, which is the factor method. Okay? So let's proceed with the next slide. So what is the learning outcome for this course or this subject? After reading this lesson, the student will be able to, so the first one, analyze the building frames by approximate method for vertical loads. So this is the first method. So this is approximation with regards to the vertical loads applied in the structure. Number 2, so this is has something to do with the horizontal loads. So as for the number 3, okay? So for number 2, this is analyze building frame with the portal method for horizontal loads. So the second one is called the portal method. And last will be the cantilever method. Okay, so same lang din siya ng number 2. So horizontal load yung pinag-uusapan natin dito, or the load which cause the sway, okay, or pag-sway ng structure. Okay, so let's proceed with the next slide. So for the introduction, so basahin natin guys. So for the introduction, the rigid frame of present-day construction are highly indeterminate. It will be seen in the previous discussion, which deals with statically indeterminate structures, that to obtain the solution for a building frame based on more exact analysis is often tedious and time-consuming. In many cases, we cannot obtain the solution without the aid of modern electronic computers. So for this reason, empirical rules and approximate methods were often used in the past by structural and architectural engineering in designing various kinds of indeterminate structures. In order to do this, as many independent equations of statics as there are independent unknowns must be available. The additional equations of static are worked out by reasonable assumption based on experience and knowledge of the more exact analysis. Even today, the approximate methods are still useful in the preliminary design and cost estimation. So yung first method natin is yung tinatawag na vertical loads on building frames. So what do we mean by vertical loads? So by the term itself, vertical, so it's either upward or downward yan. So one example of a vertical load is the dead load, okay, or the self-weight of the structure. So basahin natin yung definition. Building frames often consist of girders. So again, ano nga yung girders natin? Yung mga horizontal members sa isang frame. Ito. That are rigidly connected to columns. So of columns mo is yung mga vertical member. Ayan. Ito mga to. Ano? That the entire structure is better able to resist the effects of lateral forces due to wind and earthquake. An example of such a rigid framework, often called a building bent, is shown in this figure. Okay, so itong ating framework na to, so ito is commonly known as a building bent. Okay? So let's proceed with the next slide. So in practice, the structural engineer can use several techniques for performing an approximate analysis of a building bent, or yung frame kanina, okay? Each is based upon knowing how the structure will deform under load. One technique would be to consider only the members within a localized region of the structure. This is possible provided the deflection of the members within the region causes little disturbance to the members outside the region. Most often, however, the deflection curve of the entire structure is considered. So from this, the approximate location of points of inflection, that is, the points where the member changes its curvature, can be specified. These points can be considered as pins since there is a zero moment within the member at the point of inflection. Okay, do sa point of inflection mo, or kung saan malolocate mo yung mga pin, so makikita nyo mamaya, doon magkaaroon ka kasi ng zero moment, di ba? And we will use this idea in this section to analyze the forces on building frames due to vertical loads. Since the frame can be subjected to both of these loadings simultaneously, then, provided the material remains elastic, the resultant loading is determined by superposition. Okay guys, so the assumption for the approximate analysis for the vertical loads is discussed in this slide. Okay, so from the building bent, we will consider one panel. So, consider a typical girder. So, kukuha lang tayo dun ng girder. And in that girder, again, it is connected in this column. Okay? It is rigidly fixed. Okay? As shown in figure A. Ayan. So, given the distance L, so ang L guys dito is the distance between the center of the first column up to the distance of the second column. So, this is the distance between column A and column B. Again, from the center ha. Okay, so that L, so given ang iyong uniform load, given in omega, so the column supports at A and B will each exert 3 reactions. So, since this is rigidly fixed, so merong a moment, vertical and horizontal, and therefore, the girder will be statically indeterminate to the 3rd degree. So, di ba ito yung naging fixed girder? So, ano nga yung formula natin for determinacy of a beam? So, di ba R is greater than equal or less than C plus 3? So, knowing that the resultant is 6, since ito ay fixed, so 6 minus 3, so that is statically indeterminate to the 3rd degree. Okay. So, next, to make the girder statically determinate, an approximate analysis will therefore require 3 assumptions. So, ano to mga to? So, if the columns are extremely stiff, no rotation at A and B will occur. So, assuming that this column is stiff nga, so wala tayong magiging rotation dyan, or yung theta. At A and B will occur, and the deflection curve for the girder will look like that shown in figure B. So, ganito yung magiging itsura na deflection niya. Okay? When we assume this certain assumption here. Okay? So, ganitong kanyang deflection. So, ayan, i-discuss ito kung saan ba nakuha itong 0.21L and points of zero moment. So, di ba kanina nga, sabi doon sa mga pin, dito malolocate yung point of inflection and kung saan zero yung magiging moment mo. Okay, next slide. So, an exact analysis reveals that for this case, inflection points or point of zero moment, so yun nga, occur at 0.21L from each support. So, pakitanda na lang yung value yun. If, however, the column connection at A and B are very flexible, then like a simply supported beam, zero moment will occur at the support. Okay? So, this is under figure C. So, this time naman, if the column connection at A and B is very flexible, then we will assume that connection as simply supported. So, at point A, magiging hinge yan, and at point B, that will be roller. Okay? So, yun lang naman yung sinasabi doon. And then, in reality, however, the columns will provide some flexibility at the supports, and therefore, we will assume that zero moment occurs at the average point between the two extremes at from each support. Okay, so from that, coming from the distance of 0.1L, again, magkaaroon ka dyan ng pin. And assume point of zero moment, again, dito sa pin na to. So, ayun nga. Ito, magkaaroon ka ng point of inflection. So, ang mangyayari dyan, guys, since knowing that assumptions, ganun yung mangyayari, ganito yung magiging itsura ng inyong assumption. So, in summary, then, each girder of length L may be remodeled by a simply supported span of length 0.8L. So, kapag kinonvert mo yung lahat, ganito yung mangyayari sa kanyang model. Panibagong model, assumption. Based on this assumption, nag-produce tayo ng additional equation. Anong nangyari guys? Itong, di ba may 0.1L ka dito kanina? So, yung total span mo na L, ibabawas mo yung dalawang 0.1. Therefore, magiging 0.8L siya. And then yung 0.8L na yan, that is simply supported. And siya is nakapatong dito sa cantilever with a distance of 0.1L. Okay? So, resting on the two. Ayun, so sinabi naman dito, of the length of 0.1L. So, mangyayari dyan guys, una nyo i-compute tong nasa ibabaw. After that, itong cantilever mo. So, with that, to summarize that, the following three assumptions are incorporated in this model. So, the first one, there is zero moment in the girder. So, 0.1L from the left support. So, coming from 0.1L, so the moment here is 0. So, ganun lang din kapag dun sa right support. Same condition. The moment at a distance of 0.1L will be 0. And the girder does not support an axial load. So, walang axial load na i-carry yung girder mo. Okay? So, those are the three assumptions based on the discussion discussed earlier. Okay, so with that, let's proceed with the next method. So, the next method will be the portal method. Okay? So, next slide. So, lateral loads on building frames or for the portal method. So, for a frame fixed supported at its base, ayun. So, ito pinakita sa baba. So, points of inflection occur at approximately the center of each girder and column. And the columns carry equal shear loads. So, ganun yung magiging assumption natin dito. At mid-height and mid-length ng girder mo and mid-height ng iyong column, ang sabi dyan, they will carry the equal shear loads. Okay? So, kapag sinabing equal, so, maghahati lang sila. Okay, so pinakita naman dito sa diagram na to kung ano ba yung sinasabi dyan. So laging i-consider kung given ka ng h na height, so h over 2 lang yung mangyayari dito. Analysis. So parang pre-body diagram lang siya. So kung makikita nyo yung mga memes yung sineshare doon sa structural theory, ito na yun, yung portal method, yung mahabang solution. Pero yun naman may step-by-step process. So dito kasi, bagong reference. So, I'll try to look for my notebook. Ang tanda ko kasi nasa akin pa yan. Hanapin ko yun. Medyo detailed yung niya, step-by-step process. But otherwise, kung di ko naman makita, kabisado ko pa naman. So, i-discuss natin isa-isa. Pero dito naman sa slide na to, may present naman ako na lang siya. Parang kung anong gagawin. Summary. Okay, so, ayun. So, let's proceed with the next slide. So, a building bent to flex in the same way as a portal frame. So, in figure 2A, so meron ka dito dalawang span. And therefore, it would be appropriate to assume inflection points occur at the center of the column and girder. So, if we consider each bend of the frame to be composed of a series of portal, so in figure 2B, so nangyari lang dito guys, sinati niya lang sa dalawa. So, ba't niya sinati sa dalawa? So, ang mangyayari kasi, yung internal column mo will carry twice as much nung shear na kine-carry ng mga external column. Again, so, basahin lang natin. So, then as further assumption, the interior columns would represent the effect of two portal columns and would therefore carry twice the shear V as the two exterior column. So, because of that, nung hinati niya sa dalawa, kung mapapansin nyo naman, di ba pag pinagsama mo, itong middle column na to, ayan, ang magiging total niya is 2V. Unlike dito sa exterior column, which is V lang. So guys, ito is napaka-importanting detalye o information when it comes solving a portal method. Okay? So the next method will be the cantilever method. So, ano ba yung nasa cantilever method natin? So, the cantilever method is based on the same action as a long cantilevered beam, which is subjected to a transverse loads. So with that, it may be recalled that from mechanics of materials, from your mechanics of deformable bodies, that such a loading causes a bending stress in the beam that varies linearly from the beam's neutral axis. So assuming na ito yung cross-section ng beam mo, ito, so nakahiga lang siya. So di ba ito yung neutral axis niya? And then kapag meron kang bending stress, di ba meron kang nag-undergo ng tensile at compression. So imagine mo na lang ito will undergo tensile and this portion will undergo compressive. So because of this force P, ang mangyayari dyan, ang tendency niyan is itataob niya itong structure mo. So para ma-counteract yan, dapat yung forces mo do sa mga column, ito kasi ano na to may cover to Pero sa loob niyan may mga frames yan. Makikita niyo siya dun sa sunod na slide. So para ma-counteract yung clockwise moment nito, so dapat itong mga force na to will produce a counterclockwise moment. So parang ganun lang yung concept niyan. Ano? So in a similar manner, the lateral loads on a frame tend to tip the frame over. So yung sinabi ko kanina, or cause a rotation of the frame about the neutral axis, lying in a horizontal plane that passes through the columns between each floor. So to counteract this tipping, the actual forces or stress in the column will be tensile on one side of the neutral axis and compressive in the other side. So ito siya. Pinakita naman dito. And next slide. So like the cantilever beam, it therefore seems reasonable to assume this axial stress has a linear variation from the centroid of the column areas or the neutral axis. So with this, kailangan natin kasing mahanap kung nasaan yung centroid ng mga columns na to. So with that, i-consider natin yung cross-sectional area ng bawat poste. Okay? So nasa na tayo? So the cantilever method is therefore appropriate if the frame is tall and slender. So this cantilever method is applicable kapag several stories yung pinag-uusapan. Tall and slender. Or has columns with different cross-sectional areas. So ayan, sinabi naman dyan kung kailan mo gagamitin ito si cantilever method. Okay, so to summarize that, in summary, using the cantilever method, the following assumption apply to a fixed supported frame. So, 1, a hinge is placed at the center of each girder. And since this is assumed to be a point of zero moment. Okay? For number 2, a hinge is placed at the center of each column. So, center ng column. So, ganun din. Since this is assumed to be a point of zero moment. And number 3, the axial stress in the column is proportional to its distance from the centroid of the cross-sectional areas of the columns at a given floor level. Since stress equals force per area, then in the special case of the columns having equal cross-sectional areas, the force in a column is also proportional to its distance from the centroid of the column areas. Okay, so yung last method, hanapin ko lang yung notes ko. So yung last method natin will be factor method. Okay, so yun yung pinaka mahaba at complicated na process. So hopefully mahanap ko yung notebook at ma-share ko sa inyo kung about saan ba yung topic na yan. Okay? Okay guys, so mas maunawaan nyo kasi to kapag nag-solve natin to o kapag nag-solve tayo ng mga problems. So yung unang method kasi, hindi ako masyado familiar since hindi siya naituro sa amin. Actually, yung naituro is yung portal, cantilever, and yung factor method. So yung una, naaral ko naman siya pero madali lang siya. Madali lang sa totoo lang. Meron ka lang step-by-step process na kailangan mong alamin kagaya ng mga ibang method. So mas maunawaan nyo to kapag nag-solve tayo ng mga practice problem. So ano lang naman to, step by step process na kakabisaduhin nyo lang and madali lang naman siya. Again, just like the complex task, napakadali ng solution. Ang mangyayari lang talaga, sobrang haba ng solution natin na tanda ko before nagko-consume ng at least one newsprint. Malinis na yung solution na yun. Wala mga pawit-pawit. Okay guys, so see you on our next video.